In this video, I'm going to talk about how to shade a solution to a set operation problem. And what I mean by that, if you see a problem like B and C here, these are examples of this type of problem where you're asked to find the regions in a certain set operation. And that also just means to shade. So you could have a problem where it just says shade the regions, A complement intersect B complement or something like that. So there's some steps up here listed out that'll help you walk you through how to do this. Step one is to draw a diagram. So a Venn diagram, you can see I drew that here. In the case of B and C, we only have two sets, A and B, so that's why I drew a two-circle diagram, but I'll do an example in a minute with three circles. And so then the next thing we're going to do after we draw the Venn diagram is we're going to label each section with Roman numerals. And here's a review of Roman numerals in case you're not familiar. And these are all the Roman numerals at the bottom and what number they represent. And the reason we use Roman numerals is because oftentimes sets will contain numbers. And so we don't want to wonder, oh, is that number referring to the region or is it an actual number in the set itself? So that's why we use Roman numerals so we don't get mixed up. Okay, so the way I'm going to label this, I'm going to label this region 1, this region 2, this region 3, and then the outside is going to be labeled 4. And so there are 4 sections to this Venn diagram. There's always 4 when you have two circles. I'll label them like that. Another thing that can be helpful is you can label or write down what Roman numerals are in set A. So set A contains Roman numerals 1 and 2. Set B contains Roman numerals 2 and 3. Okay, and then the universal set is Roman numerals 1, 2, 3, and 4. So those are all the Roman numerals in the entire picture. And you can use this basically to do any type of problem with set operations where you have two sets. So now we're going to actually go through the problem using the Roman numerals. So for B, it says find the regions in this set A union B complement. So when we do this, we always have to start inside of the parentheses first. So we're going to do A union B. So first, step 1, so I'm going to do A union B. And I'm going to do that by combining A and B together. So I can either look at the picture and see that A and B all combine together because that's what union means. We can use the word or use the word combine. We're combining these together. So we're going to have 1, 2, and 3, or you can look at the sets up here. We can just take 1, 2, and 3. I don't have to write down 2 twice since it shows up in both sets. So 1, 2, and 3 are all in A union B. And then step 2 is to find that complement. So A union B complement. Well, if 1, 2, and 3 are in A union B, then the complement is going to be whatever is left or outside. And so you can see from the picture 4 is outside of that union, or you can look at the universal set, it all listed out, and 4 is the Roman numeral that is not included in A union B. So 4 would be the answer there. But we want to actually shade that region. So I'm going to shade everything outside. And usually there's a little bit of a region. I drew a pretty tight box here, but everything outside of those circles. And so that would be the answer to B. And then for C, we're going to approach it a similar way. We're going to, it's just a different problem. So there's no parentheses here, so we don't have to worry about that. But since there are complements on A and B, we're going to do those first. So step 1 is we're going to find A complement. And we know that A is 1 and 2, so A complement is going to be 3 and 4, since complement means what's not in A, so the other ones that are missing from A. And then step 2 is going to be to find B complement. And if B, I look up top here, has regions 2 and 3, then I'm going to include 1 and 4 for B complement. And then step 3 is to find the intersection. And remember, that means the phrase we want to think of here is in common. So what do those sets have in common? Well, if we look here, they both have 4 in common. So our answer is going to be region 4. And if I shade it, you look, it actually produces the same picture as above. So part D asks, what can we observe about these two sets? They're the same. So let's kind of take a look. We've got two different problems, the complement of A union B or the intersection of A complement and B complement. They're the exact same. And De Morgan's laws, which I've got a little table down here we can look at. De Morgan's laws are a set of laws that basically just say the exact thing that we just discovered. It says that the complement of A union B is the same thing as A complement intersect B complement. It also says, and we didn't show this in our examples, but it also says that the complement of the intersection of A and B is the same as the union of A complement and B complement. So these laws aren't anything that I would worry about memorizing or anything. I think that it's always best to kind of go through the problem and find the solution yourself rather than just rely on the laws. But the laws help, you know, support what we just found, which is nice. So the last thing that I want to do is I want to do an example where we have 3 circles. So I'm going to approach this problem similar to the last two. Since I have 3 circles, I'll label them A, B, and C, and then I'm going to go ahead and I'm going to label each region with Roman numerals. So I'm going to call this one 1, 2, 3, 4, 5, 6, 7, and then 8. So there are 8 different regions in the Venn diagram with 3 circles. You don't have to label them with the Roman numerals exactly how I have, although I do think it's helpful to be consistent. And throughout all of my videos and the notes, you'll see that I label them like this. I've also seen many textbooks, written by different authors use the same system with how they label the Venn diagram. So it's probably helpful to just consistently label it like this. And so like before, I can even list out all the different sets. So A is 1, 2, 3, and 4. Set B has 2, 3, 5, and 6. Set C has, let's see, we can do it in order, 3, 4, 6, 7. 3, 4, 6, and 7. Okay, and then the universal set is all of them. So 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, and so now we're going to go ahead and we're going to work through this problem. So we've got A intersect, B intersect, C complement. So step 1 is going to be to do inside of the parentheses. So step 1, we're going to do B intersect C. Okay, and the nice thing is I actually have these written right on top of each other so we can see what they have in common. So it looks like they both have a 3 in common. They both have a 6 in common. So 3 and 6. Okay, and then the next thing we're going to do is we're going to find the complement of that. So B intersects C complement is whatever's in the universal set that's not included in B intersects C. So if B intersects C has 3 and then 6, then I'm going to list all of the other numbers except 3 and 6. So 1, 2, skip 3, 4, 5, skip 6, 7, and then 8. So all together I should have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 altogether between B intersects C and then its complement, which is what I should have. And then the last step, so that was step 2, and then step 3 is I'm going to intersect A with that set. So A intersect, this set right there. So what I can do is I can actually write A. I'll write A right below it. So A has regions 1, 2, 3, and then 4. Okay, so this is set A. And then I'm intersecting it with this last step, so B intersects C complement. So I'm going to look and see what they have in common. They both have region 1 in common. They have region 2 in common. And then it looks like they have region 4 in common. So that is going to be my final answer. So I'm going to write out A intersect B intersect C complement is equal to the set with 1, 2, and 4. So those are the regions. And so then to shade my answer, I'm just going to go ahead and I'm going to shade where I see those Roman numerals. So I'm going to shade where I see 1, and I'm going to shade where I see 2. I'm going to be careful not to shade 3 because I don't want to include that, but I want to shade 4. And so that is the visual. So technically that is the answer since the problem asked me to shade that solution.